Ah, brilliant. It's so lovely to see everyone and that we are on. And I can see people seeing what's going on. Hi, my name's Josh, and I'm going to be, I'm really looking forward to actually today. I've been looking forward to it for a while. This is my first live stream with AimHi, and yeah, I just think it's going to be really good fun for us all. Yeah, so my name's Josh. We're going to be doing a bunch of really wonderful things regarding biology, hormones, the nervous system. I am a science teacher at a school in North London, and I've been teaching science for 5 years at this school, and for a number of years before that as well. So I mean, I absolutely love science one way or another, but it's lovely to see everyone online at the moment. I wanted to start off with a little bit about me, I suppose, that people can kind of see. So this is a picture of me when I was 2 years old, and I just wanted to give you guys a little bit of an idea of who I am. So I want you to look at these and see if you can work out which of these is the lie of all of these facts about me. So one of them is that I'm a proud ginger, biology is my specialism, 3 nieces and nephew, I was a world record holder, I've acted in Harry Potter, I've won 2 eating competitions, and I have skydived. Now what I'm going to do is I'm going to post this on the chat, so hopefully you can see that, and then what I'd like you to do is go to that website, if you can, and then I'm definitely a ginger, says Miz. Yes, I am definitely a ginger. It has not died, I promise you that much. Oh, Olivia's a ginger too. I am so glad that we have other gingers in the house. This is amazing. Ginger people are obviously the best in every way. Oh, we've got many gingers here. This is fantastic. I'm so glad that we have the ginger community here to do some biology together today. It seems that the straw poll that I originally thought isn't quite working, which is absolutely fine. But anyway, on the chat, that's absolutely fine. On the chat, why don't you tell me which of these do you think is the lie, one way or another. So I've got a number of different people. Someone thinks that the 3 eating competitions, that's the lie. Someone thinks that Harry Potter is the lie. What else we've got? World record is the lie. That's really interesting. And yes, going ginger in the summer definitely counts. If you dyed your hair ginger, absolutely, that definitely counts as well. I think that so Miz thinks that skydiving is the lie. Vendible sugar, that's the one. I said that the 2 eating competitions are a lie. That's right. Oh, someone thinks that I've eaten 3, not 2. Okay, interesting. So I'm going to give you some answers now. The answer is that the lie about me is that I have not even done 1 eating competition, let alone 2, let alone 3 that some people think I've done. And I actually have proof for all of this as well. I want to show you this. Well, obviously I'm a proud ginger. Being ginger is fantastic. Biology is my specialism. I studied psychology at university and focused a lot on biopsychology, so psychology about the brain and things like that, and biology, sorry, about the brain. It was really, really interesting. Neuroscience. And yeah, so this is my family. This is my mum, my nieces, and my nephew. This was a lovely photo that was taken this summer for my nephew's bar mitzvah, and aren't they all wonderful and adorable? This is me at the time winning a world record. I was one of 352 people dressed as Spider-Man in one place at one time. But about, I think 6 months later, people in Sydney decided to do the same thing, and they actually beat us. I think they got about 400, which is a little bit... I mean, look, what it is. For a time being, I was a world record holder. So that's that. This is me in Harry Potter. That kind of ginger tuft that you can see in between Daniel Radcliffe and Emma Watson was me when I was 16 years old. And this was me in The Order of the Phoenix, the 5th film. This is very near the end, when they're all kind of walking towards the train station at the end of the film. And yeah, I actually couldn't see that image when I watched the film up on the big screen. I've had to really zoom in for this, which is pretty cool. Can I do magic? I can actually do magic. I think everyone can do magic in their own way, and I can show you some magic. Maybe we can do a whole AimHi on magic and doing magic and sleight of hand and other things like that. Unless you mean fake magic, and the magic you see on like Lord of the Rings and other wonderful things. I can sort of do that, but I'm not necessarily going to tell you the secrets. Only the ginger people here will know how to do, you know, proper magic. This is me skydiving. And it took quite a second or two to get the actual position for this picture to try and look like Spider-Man. Obviously, no, not Spider-Man, sorry, Superman. But obviously Superman doesn't have someone strapped to their back, but oh well, it is what it is. And I've got in my mouth open at the time, and I don't think anyone knows necessarily that if you open your mouth when you are skydiving, all of the saliva that's in your mouth will just completely evaporate. So I really, really do not suggest opening your mouth up while you're falling at that speed, but it was brilliant fun. And I kind of want to hear about you all as well, to be honest. So if anyone can on the chat tell me like a fun fact about themselves, maybe a hobby they enjoy, maybe their favourite science, and maybe someone they identify as on the right of these 4 pictures of A, B, C or D, sort of someone with an I above their head, B with a disco ball, C who's like chatting, or D who's just looking a little confused. I'd love to see in the chat some people saying a bit about themselves, who they are, and yeah, just maybe a fun fact. That'd be really cool to read out. No, I didn't get any injuries. So OMHNPH loves playing piano. That's really cool. Get Out of the Freezer is awful at biology, but needs it for as one of their career options. That's really cool. What career option are you thinking of doing? Yes, Mia's psychology 100% counts as a science. It uses the scientific method. So psychology is brilliant. I mean, I did psychology at university. I got a BSc, which is a Bachelor's of Science. It is a science, 100%. Olivia 2008 has costume and clothes design. That is so cool as a hobby. I love that. Leonardo Pes is feeling A and C, so you're feeling like you're observing things and chatting. Oh, cool, Get Out the Freezer. You want to be a doctor. Brilliant idea. Vendible Sugar is a C, sort of chatting here and there. That's wicked. Leonardo Pes like space. Olivia 2018 wants to be a lawyer. Fantastic. I love all this hobbies and things that people have. OMH loves playing Fleur Elise on the piano. That's actually one of my favourite songs as well. I guess it's one of the few that I really know on the piano either way. But I'm going to start moving on just for time's sake, but really love to see what people have. Sibs wants to study neuroscience. Amazing. I would love to talk to you about neuroscience if you've got any time. That's really cool. Neuroscience is one of the... We actually, in the course that we're doing, we're going to be looking at neuroscience using the brain and the eyes, for example. So that's really brilliant. And all science, says Olivia 2018. Yes, I also love all the sciences. So I kind of want to show you a little bit about what the course is going to be. Just a heads up, there's going to be a bunch of words that's going to come up. It's just because it's the whole course in one. And I don't know about you, but I am as excited as this kid right here, who's clearly writing some sort of something for their school, and I know just how excited they are because I'm that excited right now. So the course is going to be, to start with today, sort of intro a bit to me and what homeostasis is. That's what we're going to talk about today. Then we're going to look at the human nervous system, which is going to be great for those thinking about doing psychology or neuroscience or medicine. Reflex actions, the brain, which is my personal favourite as a neuroscientist. The eye. Then, so that bit is sort of the nervous system section. Then we're going to go into the orange section, which is controlling blood sugar, diabetes. Then we're going to go into the pink section, which is human reproduction, the menstrual cycle, fertility control and treatments, and then finally finishing off with the green section, which is plants and their hormones. I'm not expecting to get through all of that, each of those in one session necessarily. I've just got to plan all that and we'll get through as much as we can. So stay on with the course. This could take quite a while. Who knows how long this could take. This is going to be quite exciting. But I'm really looking forward to spending that time with you all. I suggest for everyone to make sure they've got a Word document up, maybe some Google Docs or Apple Pages, or even a pen and paper, like old school, you know, crazy stuff. But yeah, if you'd like to make some notes, that'd be really helpful, especially if you're wanting to do, if you're doing biology for GCSE, or even biology for A-level, or even you're in Key Stage 3, Year 7, 8 and 9, and you're just really wanting to get to know some of this stuff. All of this will come up in GCSE and A-level. In biology. We are going to talk about the body in parts, sort of aspects of the body, so the eye, the brain. We'll be talking about the nervous system. When we talk about diabetes, we talk about the liver, the pancreas. In human reproduction, we talk about the reproductive organs. In plants and their hormones, we'll be talking about plant bodies and things like that. So just take a moment to get yourself a pen and paper or something that you want to take some notes in, if taking notes is something you'd like to do, and I think it'd be really helpful for you. So I'll give you a couple of seconds for that before we get on with this question. So while people are having a think and having a look around for maybe something they can take notes on, I kind of want to ask you a bit of a question, quite excitedly. Could you survive in a desert which is 100 degrees C? Now, just to let you know, on the Earth, there's nowhere that has an air temperature of 100 degrees C. It's not doesn't happen on Earth naturally. The highest temperature on Earth was, I think, around 57, nearly 60 degrees C. in Death Valley, right, which was a very, very, very hot place. That's so hot that you could fry an egg on just a piece of metal, just at that temperature. But I want you to, in the chat, tell me, is it possible, do you think, to survive in a desert which was at 100 degrees C? Leonardo Pescens, not really. Olivia's talked about sweat, maybe being a way that the body can try and survive there. Anyone else got some ideas? Could you survive in a desert there? Oh, I can't pronounce, is it OMHNPH? Is there a way of saying that out loud? If you had food, water, shade in the house, nice idea. So if you had food, water, shade in the house, that would be brilliant. Yes, of course, you could definitely survive that. I'm talking about someone who's just outside, they have maybe some supplies on them, that's a nice idea. Mears thinks it is possible. Leonardo Pescens, what about the core? Yes, so the core of the Earth is much hotter than that, but we wouldn't consider that air temperature. It's DS27 thinks yes, cool. Vendible Sugar thinks through luck. I love that. Get out of the freezer says bring a fridge. Why not bring a freezer? Get out of the freezer. But fair enough, yeah, you can bring a fridge. And we've got sweat as a brilliant way to support your body. Drinking water, a great way of supporting your body there. You think as long as there's water available, I love that idea. Olivia 2008 thinks, I don't think you could survive for that long. Leonardo seems really quite strong. You don't think it's possible to live. All right, this is really interesting. Okay, so I'm going to give you some ideas here to give some answers, because theoretically it is completely possible. Even though 100 degrees C is the temperature to boil water, that is incredibly hot, that's dangerously hot, but it is totally possible to survive. And what people are talking about already with drinking water, being sweaty, can be ways to get your internal body temperature down. So let's have a look at this. This is an amazing experiment that an absolute lad called Charles Blagden in 1774 did, which is called Observations in a Heated Room. Okay, Observations in a Heated Room. He got a bunch of people, as you can see in this image, including a dog, actually. I think it was Charles Blagden's actual dog, just to get into the room as an experiment. Into this room. It started at 38 degrees C, and then that temperature slowly increased. On the chat, can you tell me what temperature you think this room got to? The highest temperature. Yes, the dog did actually survive as well. Thank you, Miz, for asking the question. Yes, the dog definitely survived, which is amazing in itself. They use the dog as a kind of thing. Miz thinks, hold on, I can't, 000, that's 10 million degrees. Olivia thinks 300 degrees. Vendible Sugar thinks 150 degrees. Anyone else got any ideas? OMHNPH thinks 110 degrees. That's a bit closer to the true value. About 70 degrees since Sibs plays. Interesting, interesting. So the actual answer is 127 degrees C. That's the temperature it got to in that room, which is unprecedented. When they started this room, sorry, they really didn't think it was actually going to get to that temperature of 120 degrees C. But it did, and they were all okay. They came out, obviously hot, feeling uncomfortable to say the least, but they all came out alive. Now, what people were saying before about our bodies sweating to get to decrease our internal you're sweating just thinking about it, brilliant. To decrease our internal body temperature to 37 degrees C. 37 degrees C is the internal body temperature we want our bodies to be. We want them to be 37 so that our internal cells can do what they need to do in an appropriate way. Those who know a little bit already about enzymes might know that enzymes will work better or worse depending on the temperature. If the temperature is too high, they can denature and break. If it's too low, they can slow down and not really work. So having that perfect degree at 37 is brilliant. I mean, I don't know if you guys know, but there is a temperature. If your internal body temperature gets 4 degrees above or below 37, that's 4 degrees. If your internal body temperature, the temperature of the inside of your body, gets above or below 37 by 4 degrees only, then your body starts to shut down. Your body starts to break. There are different parts of your cells which will stop working properly. So the fact that these people were surviving at 127 degrees outside them proved to Charles Blagden that there are amazing systems in place in our bodies that help us to regulate certain things, including temperature. And there's lots of other things that we have to regulate as well. And this gets to the idea of homeostasis. Homeostasis, which ultimately means staying the same. Ultimately, homeostasis just means staying the same. Now, we want our internal body conditions to stay the same, and I want you all to have a bit of a challenge here. All of these different sort of little statements, these little bits, are all part of the main definition of homeostasis. I'd like you all to tell me the order in which they should go in. So can you type into the chat which one, do you think is the first one that goes in? Do you think, for example, is it for function, what you need to do, or to keep optimum best conditions? What can people tell me is the first one? The regulation control says it's DS27. Excellent work. I'm so sure that you used the capital T there to help you. What's after the regulation or control? Can anyone think they can tell me? Good work, Sid Plays. You've got that as well. The regulation. So the regulation, the control of something. Of a cell, when brilliant work there. Vendible sugar. So it is the regulation or control of a cell or an organism. Get out of the freezer for function. Nice idea. In response. Brilliant. There we have it, Olivia. Good. In response. The regulation control of a cellular organism in response to internal and external changes. What's next, do you think? To keep optimism the best. Good work. So it is the regulation control of cells or organisms in response to internal and external change. Oh no, that's me being so silly. Wow, that is awful. There's a full stop there. That was awful from me. I think actually the regulation control of a central organ to keep optimum best conditions. No, sorry. I can't believe I've forgotten my own thing. There we go. Of the internal conditions. There we have it. My gosh, I'm so sorry for my own fumble there. To keep the optimum conditions. I'm just going to throw it out there because clearly I've made a bit of a mistake myself. But you know what? That's okay. Mistakes can be made. If anyone is typing in or if anyone is writing some things down, this is obviously quite a bit of a definition. It's quite a big definition. And obviously it's quite a lot of jargon. So the thing I want you guys to do is tell me what to type in to get an in other words. If you were saying this definition to kids maybe, or to younger cousins, younger siblings, maybe people all over the world who don't really know that much about biology to begin with, could you break this down into a simpler version just to make it easy for us all to understand? So what is homeostasis? Well, it's the regulation or the control of a cell or organism of its internal conditions, like temperature, to keep optimum conditions for its function, and it's responding to internal and external. That is a huge amount to say. Thank you for everyone saying that I make mistakes. Yes, everyone makes mistakes. I appreciate the support. But yeah, would anyone like to type in anything? Oh, hey, got something from Get Out the Freezer. When things on the outside change, the inside of the body changes to keep itself working the same. Oh, I really like that. When things on the outside, it's actually outside and inside, change, the body changes to keep itself working the same. Such a lovely idea there so far from Get Out the Freezer. We've got vendible sugar, the body responding to outside conditions to keep the temperature inside the same. Vendible sugar, that's a brilliant, brilliant statement for homeostasis, specifically homeostasis of temperature. But homeostasis is about loads of different things keeping the same, right? Lots of different things, including temperature. So brilliant idea if we were talking about thermoregulation, we call it. Thermoregulation is internal body temperature. We've got Olivia, 2018, 2008, when something changes due to a condition, that thing can be in its best state. When something changes due to a condition, okay, cool, so that the thing can be in its best state. Oh, I love that idea. So that kind of idea of being in the best state. So working the same to be in its best state, so idea of optimal condition. I really like that. I think we can keep that for as it is. When things on the outside and inside change, things like temperature, things like how much water are in your body, for example, the pH of your stomach, it should be low and acidic. For example, how much sugar is in your bloodstream. The body will change to make sure it keeps itself working the same way and to be in its best optimal state. I love those. If anyone wants to write things down, that's really helpful. I'm going to figure out a way to upload these PowerPoints to you. I guess this is recorded, so you can go back from there, which is really cool. Leonardo Pace has said, for the body to control the things on the inside to survive and do stuff. I love that, doing stuff. How about functioning properly, functioning correctly? I love that. So here are some other ideas that we can go forward with. Well, I kind of wanted to share a bit of a poem. It's by quite a famous production that many people may or may not know about already. I wonder if people can actually tell me what the poem you think is about, who can name where it's from, and how it's related to homeostasis, So it's better by far to keep things as they are, don't mess with the flow, no, stick to the status quo. Oh, so Get Out the Freezer has clocked that this is High School Musical with this beautiful poem from their song Status Quo. Well done, Sibs Plays has got it as well. High School Musical. What's it about? You know, how is this related to homeostasis? In the actual in the show itself, what they're talking about is how there are different people all over the schools, and for example, the jocks or the brainiacs or the all different people, and they have a certain way of doing things, right? The jocks are good at their sports, the brainiacs are great at their studies, but these people are coming forward and saying, actually, no, I'm really great at other things, and that's brilliant for them. But all the other people in the group are saying, no, stick to the status quo, stick to what we're doing, stick to what all of us are doing. And that's kind of similar to what the body does. It's like temperature goes up, and our body's going, no, don't do that. Reduce the temperature, stick to the status quo. Let's see what two people have got some ideas from. Got to keep things the same so they're working well. I love that Get Out the Freezer, great idea. I didn't know there was a series, actually. I think this is just a film. This is what I've gone from there. Olivia, 2008, says it's about things staying as they should. Brilliant work. So yes, it should be that our internal body temperature is 37 degrees C. We want that to stay about the same. Yes, so Leonardo Pez has got that. It's about staying the same. Lovely. That's all about what homeostasis is. Keeping our conditions for our bodies the same. Keeping them as close to the perfect amount as possible. When we have a big meal, the blood sugar, our blood sugar goes up. The sugar in our blood goes up. That's okay, that's normal. And we have internal components of our body that reduce that blood sugar. Because if it was too high for too long, that could be unhealthy. So, the question I want to answer, just to finish off with today, is how is homeostasis coordinated and controlled? Okay, coordinated and controlled. We're going to start with this. Now, this system is automatic. When you get hot, you don't think, I'm going to sweat, and you kind of push the sweat out of your body. No, you don't. I mean, if you could do that, please hit me up. We'll make like as much money as we can to sell your incredible superpower to the world, one way or another. But as far as I know, no one can automatically just push and get the sweat out. Usually it's automatic. If your sugar goes up in your body, you don't think about reducing it, it goes down automatically with your body. So this is an automatic system, and it's made out of three things, and they respond to a stimulus. Okay, so the stimuli could be, for example, temperature. That could go up or down. We've got sugar levels that could go up and down. We've got water levels that could go up or down. We've got, what else? pH levels in the body. There's salt levels, for example. There's a number of different things that are stimuli. So if the temperature goes too high or too low, we have too much or too little sugar. We have enough water, not enough water. The pH of our stomach should be about pH 1, very acidic. If that gets too high or too low, our body tries to fix that. If there's too much or too little salt, which is quite exciting. So how does it do that? Well, this is that first bit, the stimulus down there. Then it goes to what's known as our receptor. So I'm going to move on for a second. Our receptor, these are cells that detect stimuli. So this image on the right is showing a certain type of receptor. This is a skin receptor, and it will detect the touch, stimuli of touch. Okay, so if something hurts you, that will detect that. We have a coordination center, which is, for example, the brain, or something like the pancreas, which we'll be looking at later for diabetes and blood sugar control, which receives the information from the receptor, processes it, so sort of thinks about it, what should we do, and then organizes a response. It then tells the body what to do. Okay, it then tells the body what to do. So in the case of getting too hot, there's a part of our brain which will release hormones into our blood, which will make us start sweating, which is brilliant. And the final bit is the effector, which responds to the change. Okay, it actually does something that's going to make the change. In this case, the two types of effectors are muscles. So for example, if something scares you, when you jump away from it, without thinking, that automatic system, then your receptors, your ears, have heard something scary. Your spine does a reflex, that says to do a reflex and get away from it, and your effectors are the muscles quickly move away in that condition. Your response is to move away. Or things like glands. Okay, so you've got your muscles, which can make you move away from things. Or for example, if you're cold, your body will shiver. That's a good idea of muscles. Your body will shiver. Your muscles are going to be vibrating to do that. And sort of contracting and relaxing quickly, not vibrating. And your glands are in all sorts of parts in your body. These are your thyroid glands, they're in your throat. You've got glands in your brain. Parts of your glands are, for example, your pancreas. And they will release hormones and make your body do things one way or another. Okay, now that's where I'm going to finish off for now, just because of time's sake. And, you know, we've come up to half an hour. It's been a real pleasure to talk to you all. Next time we have a session next week, Wednesday 2 o'clock again, same time. We're going to look at you making your own flow diagram on how the body detects a stimulus. So the body feeling cold, you know, how does our body respond to that? You're going to think about that. We'll have a little recap before it, and then we're going to move on to this idea of feedback, negative feedback, and we'll see how far we go on there, which I'm quite excited for. Oh, there's that. So hold on, let's go back to the course. So this is the course that I'm going to finish on, just so you can have a see as we finish up. Today we looked a little bit at what homeostasis is, and I've got some beautiful ideas from people about how it keeps our bodies the same. And as Leonardo has talked about, fight or flight, you know, yes, our bodies are incredible, says Miz as well, fight or flight. We look at that, and we look at the human nervous system and reflex actions. So fight or flight is very connected to reflex actions, looking at the brain, the eye, and that's all part of our nervous system, see how far in that we get. And then I hope to go forward into controlling blood sugar, diabetes, then looking at human reproduction and the reproductive systems and the menstrual cycle, and finally finish off with the wonderment that is plants and their hormones, and incredible learning about how they work, how they grow, and why they grow towards certain things and away from other things. I mean, that's a really cool part of the course there. So it was an absolute pleasure to talk to you all today. Thank you very much for this and the opportunity to talk to you all. I hope you learned some wonderful things, and yeah, I look forward to seeing you next week. See you later.